Like, does it mean that scores are going down, or are they becoming less precise? Like, I don't know. I don't know what that means. So what we've done is, and I'm going to be analyzing a lot of that to try and answer those questions of what the impact is of the yellowing, because I've been keeping track and I can match that back up with the data that I have. But we created a new protocol that I have confirmed with both of the creators of the Vegemeter, so Werner Gellerman and Igor Ermakov, and they agree that this should not be problematic at all. So when you're thinking about how to clean a device like the Vegemeter, you want to be thinking about, will any of the cleansers damage the glue holding the lens? Because it's an expensive device and you don't want to mess that up. And will it damage any of the plastics involved? And none of this seems to do that. So what we've started doing is we do not use tissues, because even though the handbook that may come out with the Vegemeter says just use like a Kleenex that doesn't have lotion on it, those are plant-based and they can scratch the lens over time. So we built our protocol based on what is done with microscopes, because they're also optical lenses. So instead, we always use lens paper. Microfiber claws seem to just push the oil around and not always pick it up. So we're using lens paper to clean the lens. We're washing the finger cradles regularly. Between when we do every calibration, you can see this little vial of this bottle of residual oil remover. We put a drop of that on a little piece of tissue, or not tissue, but the lens paper. And we start in the middle and work our way out in a little spiral to clean off all of that extra oil that might be accumulating over time. And then we take a clean lens paper and wipe that off too. Then you put the finger cradle back in, go on your way. And then we've always, between every participant, wiped down the finger and cleaned the lens with either lens paper or something else. But we've standardized, again, regularly every single time it's with lens paper. So this, since I implemented this in March of 2022, all of my white sticks are still white. Like, it's completely changed that yellowing and it's prevented it from happening. So that might not be a big deal if your lab isn't collecting thousands and thousands and thousands of scans, but it's something to keep an eye on. Like, if you're having a hard time getting your Vegemeter to fit within that calibration range, check that. Ask for them to send you new white sticks, because they've never made me even pay for them. They just send them to me. So that's one thing I wanted to bring up and make sure that I put out there as something that I have found that was important. To go into the second half of just the next few minutes of what I'll talk about, as I've been going through and working on a paper, it's in submission right now, so hopefully it'll be published soon. We pulled data, Vegemeter data, from over 2,000 kids. You can see up here 5 different states, 4 in the US, 1 in Mexico, 25 different programs, a whole bunch of different types of organizations. Some were nonprofits, some were schools. And you can see how I plotted all of this by site. So you can see the error bars and what the mean score is versus the overall average score for our, like, across all of these children and youth. This is a pretty standard mean score for all of the populations that we have measured. It doesn't seem to match up when I look at the Vegemeter literature. Lots of other people have much higher mean scores, and I'm not sure what that's from. We've only had, as you can see, one group that broke the 300 level in terms of mean score, and they're all pretty low. What I did start seeing as I was looking at these data, though, and really digging into it again across all of these different studies, is I started to see some systematic things too related to finger size, and age, and um, and score. So age and score versus age category, like elementary versus high school, like those were correlated with score. And I started talking with Werner about this, and we've been doing a study in the last couple of years. That's part of why we were collecting these thousands and thousands of data points in 2022, where we're looking at how it's a couple potential explanations for this. One is it finger height that is causing this potential difference? Maybe it is fruits and vegetables, and just a certain age of kids always eats more fruits and vegetables than another. Um, I'm a little skeptical about that, so I wanted to test it. There are two possible other likely explanations if it's not just fruit and vegetable intake. If it's systematic measurement, then how does finger height influence it? So there's a spring inside the veggie meter that pulls down on your finger to blanch it. If you have a smaller finger, it's not pulling as hard because the spring isn't stretched as much. So it wouldn't be compressing your finger as tightly, and it might not be blanching your finger as well. There could be more blood in the finger. That could be confounding things. Or for the second option, is it a smaller finger doesn't cover the aperture in the finger cradle as well? So you're getting like a smaller surface area basically that's being measured. Either of these are possible. So I've been going through and looking at both of these things. I don't have conclusive results yet, but we do have um, some indication that again, this is pretty preliminary. It seems like from what we've analyzed so far that option 2 is more likely. And so if that continues to be the case as we keep finishing up these analyses, a potential way of addressing this would be we just work with Werner and Igor to create a series of finger cradles. So there's a little tiny one that can be used for like preschool kids, that I don't think they have any more of because I asked him about it a little while ago just to know. But there could be different sizes. So maybe there's like 4 or 5 different sizes of aperture, because as the aperture is made smaller in order to fit around the dome of the lens, it actually also makes it thicker. So it kind of addresses both at the same time. So that's one thing that we're kind of moving towards trying to understand. Okay. My last thing that I want to cover is about precision. And again, this is coming back to how I mentioned that in this, let me just pull up the image again. When we look at this summary of data in kids, all of them basically, except one, and even this one group that has a mean over 300, the error bar is still cross 300. So we can't statistically significantly say that it's above 300. All of the groups that we work with tend to have pretty low scores, pretty low Veggiemeter scores. So one of the things that I did is I've been analyzing this most recent data is we had a few people where we actually had 4 scans because we accidentally measured them 4 times. So instead of just deleting those, I looked at a couple different things. One is if we just took the first 3 scans like we typically would, what did that look like? That's kind of this first column. Then what if we took the mean of all 4 scans versus what if we took the mean of we used all 4 scans, but we dropped the one that was the outlier, the one that was the farthest away from all the other 3. And what we see, without having to spend tons of time looking at that horrendous table with all the data, you can see the mean scores don't change an awful lot. There's not a significant difference between these mean scores, but the RSD of the mean, that's a measure of precision, okay? It's the relative significant difference. It drops in half almost. It goes from a 6.33 or a 6.15 to a 3.42 without really changing negatively the average score. Potentially pretty good thing for us to think about here, related to precision and ways that we could make a small tweak that might make this better. I'm going to skip over one thing and show you one last slide. Okay, so when I plot, I'm going to show you 2 versions of this. When I plotted the data for all of these individuals, 260 something individuals, where we measured them multiple times, we calculated their score just using the average of 3, okay? Not thinking of this other possible way of doing it. But then we calculated this measure of precision. Precision declines, it gets worse. So meaning as this value for RSD, as it goes up, that means our precision gets worse. It gets worse over time. Not over time. As the Veggiemeter score decreases, precision gets worse. Okay. So if I actually put a box around where my participants usually are, it's not great. I was going to put the histogram in here. I didn't have time to do that this morning. Sorry about that. But this is my argument for why we need to start thinking about maybe adding in a 4th scan and trying to do something different to reduce that problem with precision. Because if this is what I'm looking at for the populations I work with, because they're average, I'm usually partnering with community organizations who their goal is to increase fruit and vegetable intake, but this is their reality of where people are. And it's this imprecise for people who are the average. We know the average person doesn't eat enough fruits and vegetables, so this is most Americans. Then there are things that we need to do to improve that. So that is my argument to you all, that we should start considering adding an additional 4th scan and then testing that out, seeing how that improves the precision of what we're measuring. That's it. Thank you very much.